An equation has an equals sign and can be solved to find a solution. So for example, 4x plus 1 equals 17 is an equation. An expression has no equal sign and cannot be solved unless the values of the letters it contains are known. So for example, 3a plus 2b. I could only work out an answer to that if I knew what a was worth and also what b was worth. And finally, a formula contains more than one letter and can be solved to find one of the letters if we know all of the others. So an example of a formula would be v equals 2s minus 3. Now, one of the first skills you need to be able to use when it comes to algebra is to be able to construct an expression given a certain situation. Now, if I said, for example, that I was X years old and that a friend of mine was 10 years younger than me, then their age would be x minus 10. And that's a very simple way of constructing an expression given a particular situation involving algebra. Now, if we look at the one we've got here, it tells us that a bicycle has 2 wheels and a tricycle has 3 wheels. And if I have n bicycles and m tricycles, write an expression to represent the total number of wheels. Now, what we have to do in this question is imagine numerically what would happen. So if, for example, I had 3 bicycles, then they would have 6 wheels, because it would be 2 lots of 3. If I had 10 bicycles, it would have 20 wheels altogether, 2 lots of 10. So if I have n bicycles, I simply have 2n wheels. I don't know what n is, but if they gave it to me, I'd be able to work it out using that expression. Now, the same process applies with the tricycles. Each tricycle has 3 wheels, and if I have m tricycles, then I will have 3m wheels. And what the question asks for is an expression to represent the total number of wheels. And remember, whenever we see the word total, it means they would like us to add the 2 quantities together. So that is our expression to represent how many wheels there would be in n bicycles and m tricycles. So that's how we would construct an expression. Now let's have a think about evaluating an expression. So where we're given an expression and then they tell us the values that each letter is worth, and we can then evaluate that expression. So first of all, let's have a look at this question here. It tells us that A equals 2, B equals 4, and C equals 7. And what we're going to do now is to evaluate certain expressions using those values. So A equals 2, B equals 4, and C equals 7. Now the first expression we're going to evaluate is this one here, ABC. Now, using your knowledge of algebra, you should know that ABC means A multiplied by B multiplied by C. So quite simply in this example, our calculation will become 2 multiplied by 4 multiplied by 7, which gives us an answer of 56. The next expression we're going to evaluate would be B squared over A. Remember, the line means we're dividing, so we need to square our B value and divide it by our A value. So substituting in, 4 squared divided by 2, well, 4 squared is 16, divided by 2 gives us an answer of 8. Let's look at another one, C squared minus A squared B, because they will get more and more complicated potentially on the exam. So C squared, that's going to become 7 squared, subtract 2 squared multiplied by 4. Now remember the order in which you do operations. We can do the powers first, then we need to multiply, then we do our subtraction. So this will become 49 subtract 4 times 4, and we remember that 4 times 4 is 16, and then 49 take away 16 gives us a final answer of 33. Remember how important the order of operations is, and if there's still a part of that you don't understand, then go to the unit on BidMaths and refresh your memory on what it's all about. Final example, a squared plus b cubed. So in this case, a squared will become 2 squared, b cubed will become 4 cubed. We know that 2 squared is 4. 4 cubed, we should know, is 64. So our final answer for that will be 68. So when we evaluate an expression, all we do is substitute in the values they give us. Remembering, of course, that the order in which we work out our answer in terms of the operations is of vital importance. Let's have a look now at somewhere we're going to be inserting negative numbers though. Right, now in this example we're going to do exactly the same thing, except this time some of the numbers we're going to be substituting in are negative. So it's just to make sure you're happy with doing those operations with negative numbers. So in this question we're going to say that p equals minus 3, q equals minus 5 and r equals 8. And we're now going to evaluate some expressions using those values. So the first one we'll do is 2p squared minus r. So substituting in, well, p is minus 3, so that's going to be 2 lots of minus 3 squared, subtract our r value, which is 8. So what happens when we square a negative number? We get a positive answer. So minus 3 squared is 9. So this is going to become 2 multiplied by 9, subtract 8. Remember, we multiply before we subtract. So that's going to become 18 subtract 8, giving us a final answer for that expression of 10. Let's look at another one. 3pq squared. So we notice that everything's being multiplied here. So this, when I substitute in, is going to become 3 multiplied by minus 3 multiplied by minus 5 squared. And let's square before we do any multiplication. So this will be 3 multiplied by minus 3 multiplied by minus 5 squared, gives me 25. Now we can simplify. 3 multiplied by minus 3, minus 9, and then minus 9 multiplied by 25 gives me an answer of minus 225. Now, remembering that any of these could be on a non-calculator paper, it's really important you understand this order of operations I talk about and also how to work with the negative numbers. Let's have a look at another couple of examples. The next one, we're going to still substitute the same values in. Our next example, though, will be to evaluate PQ minus QR. So what does this mean? It means P multiplied by Q, and then I'm going to subtract whatever Q multiplied by R gives me. So P multiplied by Q is going to be minus 3 multiplied by minus 5, and then from that I'm going to subtract Q, which is minus 5, multiplied by R, which is 8. Notice I've put those brackets in purely so I know what I'm working out before I do my subtraction at the end. So what's minus 3 multiplied by minus 5? Well, it's 15. From that, I'm going to subtract minus 5 multiplied by 8. Well, that gives me minus 40. So notice what I have here now. I'm subtracting a negative number. And we all know when we see those two negatives in the centre of the sum, it means we're going to add. So 15 plus 40 gives me my final answer of 55. So let's look at our final example. It's Q cubed add P R Q. So Q is still minus 5, so this is now going to become minus 5 cubed. And I'm going to add, again I'll put it in brackets, P times R times Q. So that's minus 3 multiplied by 8 multiplied by minus 5. It's worth noting that if this was a calculator paper and you could put that calculation into the calculator, then the brackets would be essential, because the brackets are what tells the calculator, for example, to square minus 2 rather than just squaring 2 and putting the minus sign in front of it. So always put the brackets in so the calculator knows the order in which the calculation should be done. Right, carrying on with this then, so minus 5 cubed. Remember, when we cube a negative number, our answer is negative. So as 5 cubed would be 125, 5 times 5 times 5, minus 5 cubed is minus 125. And then we're going to add to that whatever this works out as. So we've got minus 3 multiplied by 8, so that would be minus 24, multiplied by minus 5 gives us positive 120. So the two negatives in that calculation have given me a positive answer. So my final answer, therefore, is going to be minus 125, add 120. My final answer, therefore, is minus 5.